everybody, and welcome back to Science Salad, where every day is a mixture of fun and science. This is the season finale of the series, fun and easy science experiments that you can do at home. So for today's episode, I actually have two science experiments. The first one is a really fun one. So is the second one. So for the first one, all you're going to need is a container. I recommend see-through. You're also going to need some milk. I have about a cup of milk here. You'll need some dish soap. I don't know if you can see that. You'll need a few Q-tips. I have extra just in case. And then for our final ingredient, you will need food coloring or black pepper. Either one works. I'm going to be using food coloring. So yeah. The first step is to pour some milk into our container. Now you want an even layer all across. So you don't want to fill up the whole container though. I would say actually a cup is pretty good, even just for this size of container. Now, this is actually a very simple one, because this is our final step until we actually start the science experiment. So, what we're going to do is just take a few drops of food coloring and put them around. So I'm going to put some blue there, and then since this channel is about salads, not really, it's about science, but it's science salad, we're going to add green into the other corners. Now I'm going to move over to a top view, that way you can see what happens when we're done. Okay, so here's a top view. I'm actually just going to add a few more drops of green. So just like this. Now, I'm going to take one of our Q-tips and dip it in the dish soap. I'm going to get it nice and covered in dish soap. As you can see now, it is blue. And what we're going to do is just dip it right in the milk. Now, I want you guys to pause for a second and guess what you think is going to happen to the food coloring. So, unpause the video when you're done with that. So now that you're done with that, let's do the experiment. So here we go. Yeah, I probably should have added more food coloring. But you can move it around, and if you can tell, it's actually, it moved all of the food coloring out of the way. Why is this happening? Now, this is happening because of a chemical reaction between the dish soap and the milk. And the food coloring / pepper is just a visual for us to see that. Now, I'm actually going to keep putting more dish soap into here. Because as you can see, this actually works for a little bit, but it might be over. But what's going on in this chemical reaction? Well, dish soap actually breaks down fats, and in milk, there's fat. So what we're seeing is basically the soap that we're adding into here is breaking up all of the fat inside of this milk and doing this. Now, what does this represent? This actually represents a very similar thing that happens in us humans. So, if you didn't know, in our digestive system, there is a part in our body that actually has a similar chemical that's in dish soap. This chemical is called bile. Bile, similar to dish soap, breaks down fats, and it breaks down the fats that you eat. So, this actually represents what your digestive system does. So, on to the next experiment. So, for the second experiment, we have to go back. And when I say back, I mean way back, to the very first video uploaded on my channel. And this video was about 8 months ago, and it was me showing a scientific property called laminar flow. Now, that video originally wasn't even supposed to be a video. It was just a test to see if the video would actually go up on the channel. But you guys seem to really like it, so I'm going to go back to that. All I did in that video was just do the experiment. I didn't explain what was happening, how to do it. So in this video, or in this experiment, I'm actually going to show you the more specific details. So all you're going to need to make this laminar flow is a balloon. I actually have a glow-in-the-dark balloon, coincidentally. Electrical tape, scissors, and some water. Another helpful thing to have is a bowl, but this is not necessary. Now, our first step is going to be to fill this up with water, and this is where the bowl comes in handy. You're going to want to fill this up into the bowl and then carry it wherever you're going. It will just make things a lot easier, and I totally recommend it. So I'll see you guys back when I get my water in my bowl. Okay, So now I have my balloon filled up, and as you can see, it actually does help to have the ball, or the container to hold it in. So this is my balloon, and it does have a cool little face on it. Yes, it does. Whoa, okay. So now what you're gonna wanna do is take your electrical tape and cut out you're gonna cut 4 pieces of electrical tape. And you don't wanna have them be too long, but you also don't wanna have them be too short. So, I'm just going to cut these, if it would let me start, because this is a brand new roll of electrical tape, and I can't get the starting piece off. Come on. Okay, there we go. Okay, so now, don't make them too big, but you don't want them to be too small. So just like this. Yes, sir. I also just realized that I did forget to say one more ingredient you will need for this. You're also going to need a toothpick. That's pretty important. I'm just going to make a tic-tac-toe board. You don't want this center part of the tic-tac-toe board, aka the best part to start off with, to be too big or too small. I would actually recommend maybe on the smaller side. As long as you get the tape down, it should be good though. Okay, so now that I have my checkerboard pattern, and it doesn't have to be perfect, it's not a perfect square right there in the middle, I am going to go grab my toothpick, and then we can continue from there. So I got my toothpicks, and if you couldn't tell, I'm actually in a different spot because I have a new table. So I'm actually going to do this in a different spot. This is a little bit more open and easier to see. So now, there's a few ways that you can do this. You can leave it in the bowl, which I don't recommend, or you can take it out of the bowl, which I do recommend, and put the ball on the ground, or just move the ball out of the way. Now you want to make sure that there's nothing spiky where you're going to set your balloon, otherwise it will pop, and that is not very fun, because I do not want to get my clothes very wet. So I'm just going to set this right there. Please do not pop on me, thank you. You also want to make sure that all the electrical tape is nice and set down. A few wrinkles are okay, but you want to try and make sure that there's no wrinkles. Okay, so now that I have this set here, what you're going to do is you're going to take your toothpick and stab it in the checkerboard, but I'm actually going to move you guys real quick, because you can't really see this experiment very well. Let's see how to do this. Okay, we're going to move you facing the plants. Set this right there. That should probably work. So now, you want to make sure that you are not standing anywhere in front of this checkerboard, otherwise you're going to get sprayed with water. Now as you can see, this is definitely still water, since you can see it jiggling. So I'm going to just poke it and watch what happens. I poked it way too big. So here we go. Okay, that did not pop for some reason. I'm starting to get concerned. Here we go. Okay, that's not a very big hole, but if you can see, this looks very frozen. Now, you may be thinking, okay, this is fake. This is just like plastic or something. Not plastic. It is not plastic. It's actually cool because the harder you squeeze, the more it looks very still. And I'm actually very lucky. I got a very small hole, which means that this could last for a long time. So I'm actually probably going to start explaining the science behind this while this is going, because this is just so cool. Even though I've done this so many times, I still just look at this and think, this is amazing. And this is all because of science. Like, just so cool. So the science behind this is actually pretty simple. Now, this is called laminar flow, and laminar flow is basically the science property when everything is moving in the equal direction. If you were looking at this at a microscopic view, you would be able to see that everything is moving in the same direction. And when it does that, it makes it look like it's still, and that is such a cool effect. I didn't realize that when I was putting water in this, it was actually warm, so some of this water is warm. It doesn't matter if it's warm or cold. As you can see, we actually have quite a bit of balloon left, so this could last for a while. So I'm actually gonna go a little bit more in depth. But I guess I can try and give a little analogy. So say you're in a pool, and the pool is packed to the brim. There's absolutely no space left in the pool. Now, say everybody is swimming in the exact same direction. That would be lambda. And that's what's happening here. Everything is moving in the same direction. Even though the direction may not be exactly straight, it is, if you can see, it's kind of curved in a way. And it looks really cool. But anyways, that's going to end off the season finale of fun and easy science experiments that you can do at home. Stay tuned for season 2, which is coming up soon. And I can't wait. This is gonna be fun. So I hope you guys enjoyed. If you did, make sure to like and subscribe, and I'll see you guys next time. Bye.